This conference will now be recorded.
So am I audible? Like, is it all fine?
Yes, the audio is audible.
Okay. So yes, I'll be sharing my screen and
Okay.
what is we'll be GitHub repository. Do one thing this session. I keep on pushing that particular code to the GitHub repository so that we can keep track of what we are doing and we can access the code right after the session itself. Seems fine?
Okay.
So yeah, we'll have some node repository. That's a node. So are you aware of GitHub? So how to just use, work with the repositories.
Yes, I'm aware of GitHub.
That's fine. So let's do one thing. Yeah, we'll just create this node repository. So the session, we'll just divide this particular session in two parts. One would be getting started with the JavaScript. Can you just introduce me with the fact, like how good you are with the JavaScript concepts? How much have you worked with JavaScript in the past?
Like my experience working with JavaScript was more like doing some validations, um, like small writing small functions and operations. I was never like more deep into any of the JavaScript coding, like ES6. I don't know most of the concepts over there, but I just use it for validations and small purpose things in JavaScript.
So you're working more on the backend side, is it?
Yes. More like a backend side developer, but nowadays, like in our company, they're asking us to do the front end stuff also. But when we did an MVC projects in .NET, the front end, the UI pages, we would write it in like CS HTML, like the Razor code. We used to write it in that. We used to do it that way, and JavaScript was like comparatively, if I compare like .NET and JavaScript is like very less I have used.
Okay, not a problem. See, the only problem, when we are working with front end and back end, so if you're just having some project on the back end, if you have spent a lot of time in the background, languages like ASP.NET, Java, so some of the problem that we face is how JavaScript execute is entirely different from the execution of ASP.NET or Java. And it's really important, like if you're working with any of the front-end technology, so let's say you are working with JavaScript, Node.js is completely JavaScript based. If you're working with front-end technologies like Angular, React, Vue.js, again, they are JavaScript based. So how they execute in the background is completely different from an ASP.NET execution. So it's very important to, if you're working on any JavaScript based language, it's very important to understand how it actually executes and work in the background. So we have to master a few concepts inside JavaScript in order to work with any technology on the front end side as well as Node.js. So this session, I mean, it's easier and it's more relatable if you are good with JavaScript to work with these concepts on Node.js or any language on the front end side which you are going to use. So yeah, definitely the few sessions in the beginning, I think I would say 2 or 3 sessions in the beginning, I can focus upon the core concepts of JavaScript, because we have to get into what are the patterns in JavaScript. So are you aware of module pattern, singleton? So you might be having some patterns in the background, but JavaScript is based out of two different patterns, which is module pattern and prototype pattern. And then we have a class-based architecture in Node.js or JavaScript as well, which is lot different from what the classes that we have in ASP.NET. So in ASP.NET, when you are inheriting objects, you are creating an object of base class as well as an object of derived class. But over here in JavaScript, you never create an object of base class in the background. So things are pretty much different. ASP.NET completely different execution in the background as compared to JavaScript. So first we need to understand how, so these languages like ASP.NET and Java, they don't have any asynchronous processing. Okay, you can have multi-threading threading a program which is more of multi-threaded, but yeah, not a asynchronous program. Asynchronous is something which is getting done on a different thread. Once it's done, you are getting notified. So I don't know how much you are aware about these differences, how JavaScript works versus ASP.NET works, but yeah, we would be focused towards these concepts in the start of the session.
Yeah, okay.
Seems fine?
Yeah, it's fine. Like, it's not like I don't have any knowledge on this, but not not very much into these concepts. But if
Yeah.
I think I can pick up in like initial 1-2 sessions. I can pick up the
See,
speed.
you're working with the technology, you're new to Node.js, you're new to the front-end world, let's say. Again, you have done just the validation part, but JavaScript is entire language in itself, having a lot of concepts. It derives a lot of front-end code, both in the view part and as well as server these days, like Node.js. So if you're good with the concepts of JavaScript, most of the things are resolved by itself. So let's say if you're writing some code and if you're good with the conceptual part of JavaScript, definitely it will help you out in order to bring more solid framework. Because you're working with ASP.NET, if you don't know how objects are getting created in the background, definitely it won't make much sense for you to keep learning the higher level concepts. So yeah, I mean, you can also start working with Node.js directly with a little knowledge of JavaScript. But yeah, I always emphasize on, so my focus definitely is making you understand the concept. Coding is just a copy paste. People go how to create a file, how to delete a file. That is just a copy paste code. But over here, we are going to build up concepts. So more focus on concepts rather than just having some syntactical stuff getting done in the session. Do you agree?
Yes.
Let's build our concepts on Node.js. Let's build a solid concepts of JavaScript, and then all these Node.js, Angular, React, front-end technologies would seem very easy to you. MongoDB. So we'll be working with MongoDB in this particular session. We'll be working with Express.js. We'll be working with this particular, Node, the core Node technology. We might be putting some front-end code as well using some EJBs and some Bash technologies. So in all of these technology, just what you need to learn is a JavaScript concept. So yeah, definitely if you're good with JavaScript concepts, everything seems to be very easy. And that's my focus that would be my focus, to make JavaScript seamless for you and then make you aware of all these node concepts. Agree with the flow?
Yes.
And yeah, definitely in the entire session, be very vocal about the fact, whatever you are understanding, whatever your thought process are, so that we get a better clarity upon how the things are going on. I mean, more vocal you are, more I would be in state to understand that how the session is going on and how I need to modify it so that it can work out even better.
Yeah.
So again, as I said, we'll just dedicate a few sessions in the, sorry for today. Maybe we'll be ending this session at 7:30, 35, 40. But tomorrow I'll be there on 6:30, and then we can start from 6:30 to 8. Is it fine?
6:30 to 8 IST timing, right?
Yeah.
Oh, okay. Yeah.
So the
Okay.
time that we joined till 8 a.m.
Okay. Okay.
Okay.
Yeah.
So let's put this session more of, I won't say I'm, training you with something. Let's have a discussion session. So let's call them more of discussions, because I want you to be very interactive. I want you to discuss the technology. So we can have a thought process around some JavaScript concepts, then some Node concepts. And I wanted more of a discussion rather than a session wherein I am speaking and you're not responding back. Let's make it discussions wherein we would be involved in a technical discussions, how the things are going on, how the things should be, what do you think would happen in the background. So those sort of discussions. So I don't want to make it very boring, me speaking up, looking at the slides. So no
Yeah.
slides. I just want you to be interactive and talk to me more in the technical, like sort of discussions and sessions which are going on. Okay.
Yeah, sure.
So yep, I'll first explain. Okay, so what do you mean by asynchronous processing? So if you have worked a bit on JavaScript, let's see. What is the asynchronous processing when you talk about the JavaScript programming? What do you mean by asynchronous programming?
Okay, so synchronous programming is something like it follows a sequence, like it's like a step-by-step procedure. Like if there are like 3 steps in a procedure, if step 1 gets executed, then only it will go to step 2, then to step 3. But in asynchronous programming, the concept is like a little bit different. Even we have got 3 steps in it. It is like a parallel processing, so it will not dedicate the like the process task is not dedicated to just one step. It will like if first step is taking a lot of time, then it will go and execute the other step. It will do all a parallel execution depending upon the response of the process execution.
So the main thing that we have to focus is that this particular programming that we are talking about, asynchronous programming and synchronous programming, it's either a step-by-step process, or it is something which skips certain steps and move further. So if it is skipping certain steps, then we say it's more of a asynchronous programming, wherein things are not going in a specific order. And if we are following a very simple in a step one by one, then it is more of a synchronous programming. Okay, yeah, you're perfectly correct. So let's talk about ASP.NET. Is ASP.NET synchronous or asynchronous?
I can say that ASP.NET is a synchronous process. Like it,
How can you say ASP.NET or Java is synchronous?
so it depends upon the execution pattern. Like here we have the classes and methods. So whenever like a class is created or object is invoked, we have a particular pattern that it has to follow, and whenever it's executing in the process, it has to complete that process and go to another process. So it is designed in that way. We have multi-threading in C sharp, where it can handle like in a where it can handle multi-threads in a process, but that is, I don't think that is completely an asynchronous way of doing the programming. We are somewhere still in a synchronous process.
So definitely any Java or .NET program which you're running is more of a asynchronous program. Sorry, that's a synchronous programming.
Yeah.
Because so you're working on website in .NET.
Yes.
Okay. So in website, again, I think I talked about this particular stuff when we started up the session. Whenever you have an incoming request, okay,
Mm-hmm.
incoming request from the user to view a website is always catered end to end by a C# program, which means even if that particular request that is being received from the user, it contains multiple data requests, multiple network requests, you need to access some file system, it has to cater everything end to end, which is the user starts with a request and he is given back a response. If you are not including JavaScript into it, you can't do any AJAX calls, you can't call the APIs. What you have to do is you have to get the entire data for the website in the first go, and then you have to just provide this data to the user back. Agree? So let's do one thing. Let's get back inside an inspect window. So you need to press F12, get inside inspect window. You need to click this sources. I have certain files over here. Again, I'll delete these files. So we'll be working more on these snippets. So what we call them are snippets. So just remove these snippets, the already existing one. So again, you are just in, let's say if you have a function, this function is do something, and this function is executing. Let's say we are defining some var a equal to 10, a equal to a plus 20. Then you're doing set timeout. You're having a function. So this is called arrow function in JavaScript. We'll just talk about it in a while. But yeah, we'll just focus on concepts right now. And after a set timeout, you have a value which is, let's say, let's wait the set timeout for 1000 milliseconds and put a console.log the value of a, and let's put this value equal to a plus 50. So when we are executing this program, what do you think would be the output of this do something in terms of console.log? So what do you think it will log out during execution? Hello?
Yeah.
Ritika, you're
So
not
I
audible.
think it will be first. I think first the 30 will be displayed. So it will
Okay.
add 10 plus 20, then 30 would be displayed. And then when it goes to a set timeout, then after 1000 seconds, then 30 plus 50, 80 would be displayed.
So you're saying there would be two display, is it?
Yeah.
So it would be displayed multiple times,
Mm-hmm.
but we have just a single console log over here.
Oh yeah.
I mean, I want to just understand, how do you see a asynchronous program? What do you think would happen in the background? How does it happen? So the question should be how. How is the thing happening in the background? And that is what we are going to focus here. So
Okay.
let's see for the execution. Let's put
Mm-hmm.
debuggers rather than just making a guess of how things are working. One,
Okay.
two. So we are just putting debuggers. So let's just run this. I have to press control.enter in order to run this. So just control.enter. We are invoking this function. Let's press F11 to get inside. We are creating a variable a. So we'll be talking about something which is called scope and closures. So what is the scope of this variable? How is it creating? Where is it assigned
Mm-hmm.
with the memory and all those stuff? But yeah, let's wait. No, let's just start one
Okay.
by one. So we are creating a variable, adding 20 to it, and then somehow your main execution thread of JavaScript saw that there is a set timeout request. Set timeout means I have to wait for 1 second and then proceed further. Then, JavaScript is very reluctant. He don't want to wait for any asynchronous task. He proceeds further. Okay, he says, okay, you might be telling me to wait for 1 second, but then I'll be moving further with the execution. and then once 1 second is complete, I'll get back. So what happens is it goes to line 7, it gives you a console.log. Until this point, we have the value of a as 30, so it gives you console log. And after, let's say, a time frame of 1 second, this particular program goes back to the set timeout. It increases the value of a from a equal to 30 to a equal to 30 plus 50, which is 80. And then the line which is going to execute is line, it's done. So you are not going to continue back from this particular line 5 to line 7 to have multiple console logs. So there would be only one console log, which means the program or the function that you created, it executed. So the function that you created over here, which is do something, it executed in totality. So it waited. So you have the set timeout, which is a wait for 1 second. Even if you're telling them to wait for 1 second, it says, okay, let me go till the end of the function and then get back with the callbacks. What are the callbacks? So in set timeout, you are having a callback saying you have to increase a value of a from a equal to a plus 50. So this is called a callback function. A set timeout is associated with a callback function and a time frame. So after a time frame of 1000 millisecond, call me back this particular function, and only this callback function would be invoked. You won't continue from here, which means there would be only console log a once your function has already exited the normal execution, and then only a callback execution would be done after a time frame of 1000 milliseconds. Agree?
Okay.
Can you relate to the flow?
Yeah, but then what is the use, like having a set timeout and not able to display the like
That's a program
80
flaw.
value?
I could have done console.log.
Okay.
So anything that you have to trigger after a second, after 1 second has to be a part of this callback function. We'll talk
Okay,
about
so
all this, in detail. But yeah, now let's just execute this. So I'll just close this. So F10 now, what would happen is you're running the set timeout. It goes to line 1. So we don't have console log over here. Just 1 minute. So now let's refresh. Console.log is gone. So now basically we are console logging this value, and now you can go execute this, make a set timeout. After 1 second, this will come back. You have a value of a which is already stored at 30 equal to 30 plus 50, which is 80, and then you are consoling log the value. Okay. So somehow some awkward behavior in my console window. Yeah. So it would be 30 and 80. So first of all, what did you get out of this in a particular execution?
okay, so first of all, it's executing in a synchronous pattern.
Yeah.
It's not like having a sequence. It's going in it's not following an order. But one more thing, what I understood is whenever we have a callback, like set timeout is a callback, right? So maybe we have
Yeah, I'll
to.
explain you what is a set timeout. Set timeout is a web API. So they have a special name which is called web APIs. So set timeout is a web API being called in the background. And yeah, let's hold for that discussion for a while.
Yeah, but whenever we have this callbacks, we need to like console log the output so it would display on the screen, and that is what I'm understanding. Because if we didn't have a console log over there, it would have not just shown that 80 value, right?
Yeah.
Okay.
So what's happening? So the key points over here is whenever you are calling a function, it is executed always in totality. It starts from the first line of the function and it completes the execution at the end. And then once that execution is completed, in case you have any asynchronous part of execution, that will get triggered. So we are saying we have a set timeout of 1 second, which means after 1 second, you will be just invoking a function back, which is stated inside that callback function. So set timeout says, okay, wait for 1 second and then call that function or call that function that we have associated as a callback over here and start executing it further. Okay. So what if I tell you, JavaScript is single threaded in the, let's say JavaScript is single threaded. So now let's add the concept of how JavaScript is actually executing this do something program. If I'm telling you that this particular JavaScript program executed on a single thread, how will you try to evaluate this? And how will you compare this with ASP.NET? The entire execution that you did was a single threaded execution. If I am just
Okay.
adding this line of code that this JavaScript is a single threaded execution, then like what fishy can you think about it, about this particular execution right now?
Okay. So if it is a synchronous way of process, it will like first the value would be incremented to 30. So the A value would be 30, and so as a synchronous process, it would be going like from step by step. So the next step, it would come and stop at the set timeout. It will wait for the 1 second, and it will console log the output. That would be 80. So our first output will be 80, and then it will console log the previous output, that would be 30.
Yeah, perfect.
Okay.
So, let me reiterate. If it would have been a single-threaded execution, although this is definitely a single-threaded execution, but yeah, you being a ASP.NET side, developer, if you think about this program as single-threaded execution, what you would understand is we have a var a which is 10. You're assigning a value of 10 plus 20 to this particular variable. Then you have a set timeout. Okay, since we have a single-threaded execution, then your program should wait for 1 second to complete. Once 1 second is done, you'll just get back to line 5. You'll increment a with 50, which is like a value which is 80, and then console log that value and get back a value which is 80, and then a console log which is, let's say, a value 30.
Yeah. Mhm.
Okay, so this is a perfect single threaded execution. But over here again, I'm saying JavaScript is again single threaded execution. So definitely we are executing this program in a single threaded architecture, but then also we are getting a feel, or we are getting an output which is completely different from what we evaluated. Agree?
Yes. When you say JavaScript is like a single threaded approach, then that means it's asynchronous, right? It it can.
Again, that is what we need to understand. If I'm saying JavaScript is a single threaded execution, so I'm adding few more words to it. JavaScript is a single threaded execution model. If it's a single threaded execution model, we need to analyze and we need to know how does the asynchronous part of application works. Definitely, if there is no thread in the background to take care of stuff, in a parallel manner, how will someone wait for 1 second? So who's the person who's waiting for 1 second? Maybe it should be the main thread. In case it is a main thread, we should first get 80 and then 30. But the output that we have, let's just execute this particular stuff again. So I don't know why this console.log value. I don't know why this is not working. So okay, yeah, after 1 second it is giving me 80 value. So had it been a perfect asynchronous programming or a single threaded programming, the output should be 80 and 30, but somehow we got 30 and 80, which means that there is someone involved in the middle to take care of this timer, which has to continue for 1 second. Had it been a perfectly single threaded program, this timer would have been taken care by the main thread itself, and that is how the things happen in any ASP.NET technology. So over there, if you go and put sleep, it is the main thread which is sleeping for 1 or 2 seconds, and then once that time frame is complete, you go further and start executing it. Agree?
Yes.
So
So
in
you're saying that
ASP.NET,
yeah.
so in ASP.NET, what I was saying is, if you put a sleep keyword, then your main thread keep on waiting for 1 second or 2 seconds, and then it proceeds in a synchronous manner. But here, what we can relate is that someone is keeping this counter, and once that counter is ready, he's just responding back. So to just trigger this callback. That is the reason we are getting 30 and 80 and not 80 and 30. So it is not a very perfect single threaded infrastructure. There is something more involved to this particular infrastructure. Yeah, you were saying something?
Yeah, so like based upon this example discussion, I'm thinking like JavaScript it is a single threaded application, but we are just trying to process it in a asynchronous way. Am I right?
So the question of mine is, if you are saying it's a single threaded execution, asynchronous means someone acting on certain part of application in a asynchronous manner, in a parallel manner. Okay, so if you agree with the fact that JavaScript is a single threaded execution, how is this parallel task of maintaining the counter is getting done in a particular in this particular application? So who's maintaining that counter?
Um, so it's the same thread that's maintaining the counter.
Then it should have been halted on line 6 itself, or sorry, on line 4 itself. If you are a single threaded execution, you are doing var a equal to 10, a equal to 20, and then you are told to wait for 1 second. You are still waiting, so how can you process this value 30?
Oh yeah, yeah. So there the asynchronous execution is coming up, right?
So
So
what do you think?
whenever it's
A
yeah.
parallel execution will, there is a parallel thread somewhere, or like, just try to give a thought and we'll just see in practicality what actually happens. Yeah, you can try just,
Uh,
you can try a certain output here.
yeah, I'm thinking like it's mm, mm, yeah, I'm thinking that there is some parallel processing going behind.
Definitely there need to be something, and that something is what we need to explore. Okay,
Yeah.
so over here what we'll be doing is we are going, so we have this particular URL. I'll just copy this particular URL, and I can send this URL as a part of chat to you. You just
Hmm.
copy this particular URL somewhere. It's a great URL to learn JavaScript. I sent
Okay.
you, and just give a look to this particular URL after the session. Yeah. So
Okay.
what we have done over here is this particular application contains 3 parts. Okay. So on the right, if you see, it contains a call stack. It contains a container called web APIs, and it contains another container which is called callback queues. Okay.
Okay.
So what this particular, 3 containers represent is what happens in the background of JavaScript. So on the left, when you are executing this program, do something, we'll see these containers shifting data within themselves. Okay. What I'll do is I'll just run this for a while. I won't explain you what actually is getting done in the background or what does they represent, but let's just run this. Again, it is not running the right program. And let's refresh, close. Let's put this program again that we had in our browser. Let's get back,
Okay.
save and run. I think their website is broken or something. Close, save and run. I think they have some problem over here.
Okay, so
Give me 1 minute. Let me just open this up somewhere else. Let's try to execute what they are doing. So this is working fine right now. Edit. Let's try to edit this up. Save and run. Just not letting me update something. Maybe close the browser. So what this person Laub has done is he has put some weight inside the main execution thread of JavaScript, and he is trying to analyze how things work in the background. So again, I don't know why he's not letting me run this program of mine. Again, it is doing some. So 1 more minute. Let's open up in incognito mode.
okay.
Else, if this website doesn't work, I'll just explain you myself what is happening in the background. But yeah, just make it very visually available, so you are having a visual impactful stuff in the background, which is visually see how the things are moving in different layers. And there's incognito. Let's go
Can't
to
see your screen. It's like I can just see a black screen.
Isn't my screen available?
No, I can just see a black screen. Like, are you on any site right now?
It's a
Are you
site
on the
called
Laub
Loud.
site?
Yeah,
Oh no, I can't see that. I can just see a black screen.
I can reshare. Maybe some network glitch. From my side, it is shared. Sharing screen again. Is it visible?
No.
In GoToMeeting, I can see that my screen is shared. Just check your connection once. See on your side.
Yeah, it's all connected. Can you go to the repository and see if I can see a Git repository?
So you can't see my system. I have shared my entire screen.
Okay, I think it's like freezed. Maybe I'll disconnect and join the call again.
Yeah, sure.
Yeah. Oh, I think I can see the screen now.
Okay.
Yeah.
So yep, I'll just explain you. I don't think his website is responding fine. I have seen some problems since days over here. So yeah. Okay, so this particular line of code. Okay, let's see. Are you able to see the screen?
Yes, yes.
Okay. Can we try? I don't know. Again, yeah. So see what's happening over here on the left is, let's try to analyze what he has written over there. You have a $on button click, then you have a set timeout, then you have something which is console log high, then you have a set timeout, and then you have console.log something. So when we try to run this program, you can see that click and set timeout. So any set timeout request that you have, it goes to a web APIs. Inside set timeout, you have certain tasks that has to be done. Then that particular task goes to callback queue and it returns to callback. So let me give you just the introduction. Focus on line 9. As soon as you'll encounter a line 9, so it will move one by one. It will keep on, let me rerun this. So you can see the focus is there, which means this is the current line of execution. Focus on line 9. So I'll just execute this again. This line 9 is a asynchronous part. So this line 9, we have a set timeout, which is you have to wait for 5 seconds. After 5 seconds, there is a function that need to execute. The function name is function timeout, and it contains one line of code, which is console.log. Click the button. Agree?
Yes.
So on line 9 is an asynchronous part. Your entire code is executing in a synchronous manner. When you come to line 9, there is a set timeout, which means you have to wait for 5 seconds. As soon as that particular execution, so you can see initially everything is getting executed in call stack. Hello all, this and this. So whenever your JavaScript programming sees that there is a set timeout request or there is an asynchronous request, it makes that particular asynchronous go back to a backend thread, which is called web APIs. So JavaScript has multiple web APIs, and these web APIs has got some, each web API has got a specific task. So there is one web API that has to deal with set timeouts. So as soon as a set timeout is encountered, you are telling someone to wait for 5 seconds. So a parallel thread is created in the background whose work is just to wait for 5 seconds. Once the 5-second wait is over, a event is thrown back. So the communication of the main thread and the backend APIs are in terms of events. So an event is raised to the main thread, and the main thread gets to know that this particular web API is done with the execution. So this callback then goes to the callback queue. So let's say if you have multiple set timeouts, so you have on line 9 one set timeout, after line 11 you can have 10 more set timeouts. So each set timeout has to be handled by a separate thread in the background. Agree?
Yes.
So all of them will create separate threads in the web APIs. Those web APIs will keep waiting, but once the set timeout is over, it goes, so this entire callback function, which is this function timeout, it goes to the callback queue. Once your call stack is empty, once it has done the current execution, it will take that program and start executing. So let me rerun this. Focus on line 9. It encounters a set timeout. It goes over here in web APIs. Once it is done, it will go to this particular callback queue, this timeout function. Then it comes back to the callback stack, and then it executes. This callback stack is that single thread which is executing everything. Okay. So when you are running this program, you rerun this, you have line 1, line 7, everything getting executed on call stack. Waiting is done on time, this particular web API. Once this is done, the callback function goes to the callback queue, and then it is taken up by the call stack to execute. I'll just halt speaking and you can see that again.
Okay, Mayank, I have a question over here. So what I'm thinking, like, the way of execution is first it encounters a set timeout, so it will wait like it this for 2 seconds. So it will go to that web API where the set timeout will go to the web API, and in meanwhile it can execute console.log that is high. So that will be first executed, and then again a set timeout will come into call stack that goes to web API, and once the time is over, it will come to the it will come to the callback queue. But again here, if I have a multiple set timeouts after can you go back to the code? Yeah.
So you're telling me that in case I have multiple set timeouts.
Yeah, after that code, I think after line number 9, if I have got multiple set timeouts, and on each of the set timeout, the wait time is varying. Like one has 5 seconds, the other has 2 seconds. So in that scenario, how we can say which one will get executed first? Yeah, like this.
So what would happen is you'll start again. This is not running. Had it been running, the picture would have been much more clearer. I think they have some problems with their website.
Oh,
Okay.
okay.
So what we were doing is, let me just explain you. So let's say if you have multiple set timeout and you have this set timeout waiting for multiple seconds, let's put some variable time over here, 2000. I can put 1500, then you have this 3000, and then you have this 4000. Okay. What would happen is your compiler will start with line 2. So your call stack takes up this entire script. He'll start executing the script. It will come to line, it will start from do something. It will start this execution. It will go to line 2. So there would be a variable a equal to 10, then a equal to a plus 20. Then it encounters a first set timeout on line 4. Okay. As soon as your main thread sees that there is a set timeout request, it will trigger a background thread in order to have a counter which is for 1 second. Okay. Now there is a
Okay.
background thread which is waiting for 1 second for things to be complete. Then, as I told you, the call stack hates waiting, proceeds further, it goes to line 8. It sees that there is another
Yeah.
set timeout. Okay. At that moment of time, it will say, okay, I'm triggering another single thread in the background to keep up this timer. This timer has to be now there for 2000 millisecond. Okay.
Mhm.
It goes further. It creates another thread. It goes further, another thread. It goes further, another thread. It goes to line 24. It comes to line 25 and the execution completes. Okay. This
Mhm.
particular function, as I told you, would execute in totality. When this particular
Yeah.
function executed, it created, 1, 2, 3, 4, 5 threads in
Oh,
the background. Okay. This set
okay.
timeout. So there was a thread which is waiting for 1000 millisecond, and after 1000 millisecond, maybe your main thread that you are working might be busy with some execution. Okay. So
Mhm.
let's say the main thread that was executing, that was still busy. So
Mhm.
it went to a callback queue. He said, let the main stack complete the execution. I'm waiting over here. Meanwhile, the other set timeout, which is, let's say, 1500 millisecond, it will complete its execution. It will again be stacked inside this callback queue. So
Mhm.
having 5 callback functions which are stacked inside this particular queue, and as soon as this callback stack is empty, this queue will move the things, so the function from this callback queue to the call stack, and this call stack will one by one start executing the callbacks that each set timeout contains. So what I would expect is 1000 would be completed
Okay.
initially, then 1500,
Mhm.
so this would be executed, then
Oh.
this would be executed, 16, and then 20. But the main thing is only the waiting part is accomplished on the web API. This call stack is the actual executor of any synchronous code. So even if you have a callback, these
Okay.
callbacks are
Mhm.
not executed on web APIs. It's only the timer which is getting executed in the background. But this a equal to a plus 50 and console.log a is actually getting executed on the call stack.
Okay. So, like in our discussion, hearing that a call stack is like a more a synchronous way of processing.
It's a single
Where
thread which is actually processing everything.
it's a single thread, and can I like say that it's a synchronous way of processing where
Yeah.
it is still handling in a sequential order, and when it comes to web API, it depends upon like the API, like whatever we are sending into that API, it will wait for that time, or it depends, like for set timeout, one we have 1000, the other has 2000. So it depends like upon the time which we are sending, it will take the execution and it will send back, it will send to callback queue. So the way how it gets executed in web API, and that is being that order is being put in callback queue. And now the callback queue is also it's also synchronous processing. Like for when 1000 comes first here, then it will send 1000 to call stack. Then if 1500 comes to callback queue, it sends 1500 to call stack.
Yeah.
So
So it is
callback.
a
Okay.
FIFO approach. So let's say if you put just 10 millisecond, Okay, so maybe this 20th one. So see, the synchronous programming is really fast. Okay, what you
Yeah.
need to be focused upon and what you need to be cautious about is the asynchronous part. The asynchronous callback queues that you have, once the threads are done with their processing, it start moving stuff to the callback queue. These
Okay.
callback queues are FIFO, first in, first out. So
Mm-hmm.
20 is the first one. So the timeout of 10 millisecond would have been executed the first, then second, and so on. Let's try this out. Okay. Since
Okay.
this is not working, maybe I can try on my other laptop. If it's a website problem, then I can't resolve it. But yeah,
Mm-hmm.
this is a thought process. There's a single thread in the background. It executes in a synchronous manner. Whenever there is a asynchronous part, let's say a set timeout, other asynchronous part could be getting data from the network. Okay,
Mm-hmm.
so we'll just talk about getting data from the network in a while. But yeah, what we'll say is in a set timeout, a counter is being maintained. So you have to maintain a counter of 2 millisecond or 1 millisecond or 10 seconds and so on. So that part that has to deal with setting up the counter and maintaining the counter is taken care by some web API. Once the counter has been finished, there is an event which is being raised which says, okay, my counter is done. You take this
Mm-hmm.
particular timeout function, that this callback function, and it start executing it on the main
Okay.
thread once you are available. So this
Okay.
main thread is the executor. Whatever you write in JavaScript is always executed by a single thread, and then everything which is asynchronous is waiting in the background. It raises the event once it's done, and then the main thread takes back that execution, start executing it. So the
Okay.
entire workload has been there on the single thread for execution. And what these web APIs are doing, they are just making things easier for this particular call stack, the single thread, so that it can keep on working. It keep on assigning
Okay.
tasks to the main thread. So let's get back
Okay.
to this snippet that we have. Let's put in terms of milliseconds. So this particular set timeout has a timeout of 1 millisecond, and then we have another set timeout. Let's put a timeout of 1000 millisecond. Inside this, let's do console.log1. Inside this, let's do console.log2. Although your main thread will encounter line 5, which is the first set timeout first, but the set timeout which will actually complete in the background would be the second one, which is the one on line 9. So let's see what is the output. Let's remove this console log. We just need to see how this set timeouts are working. Okay. So what I would expect is I want this counter to this particular function to run, and then once we are done, we are first getting a value 1 and 2. So we can put another stuff over here. I can just put, let's say you have to wait for 2 seconds and you have to console log 3, save it up, enter 1, 2, and 3. Move this 3 on the top. So your synchronous programming will go in this particular manner. So let's now put debuggers. I'll put a debugger on line 3, 7, 11, 18. We'll start with the line execution 18. F11, you get inside, you execute the set timeout. A single thread is created in the background. It will tell your main thread to wait for 2 seconds, and after 2 seconds, console log 3. Meanwhile, it will go to set timeout. It will make another thread wait for 1 second. Then it will say, okay, once you are done, poke the main thread back, get to the callback queue, and from callback queue, it will do some FIFO operation. Then it goes to line 11, again new thread, which is just waiting for 1 millisecond. Once it is done, it will go back to the callback queue as soon as the main thread is available, and as soon as 16. So you won't see this console log getting run until and unless we reach this line 16. Now you can see that the current function has been executed in totality. So now is the turn of these console logs. We will get back to this console log 3, 2, and 1. So now if you see, what we were waiting on debuggers, because of which these set timeouts were complete. they got in the queue, and then we have 3, 2, and 1 rather than 1, 2, and 3. Saw that?
Yes. So with the
If I
debugger,
execute
the time.
this, yeah, the debugger time, so if I execute it normally, it would be 1, 2, and 3, because this would complete, in a single millisecond. It would complete in 1 second, 2 second. It will start queuing up inside that particular callback queue, and it will be 1, 2, and 3. That is what we got. But let's say we introduce a debugger. We are making this debugger, so we are waiting on this program, and we are proceeding, with some time. Let's take 2 seconds. 2 seconds are done. The things would have been completed in the background. Move to the callback queue as a first step. We have already
Yes.
waited for 1 second, so let's wait for 1 second now. We are done. The things might be done in the background thread in the callback queue, but we are still working on this function, so callback queue function, these callback functions won't be triggered because we are already executing the current function. So once we are done with this set timeout, now all of these set timeout will start working. It will start enqueuing. It will start getting back to the stack. I expect this to run first, then the 8th, then 11th, and so on.
So this is because in the callback queue, first 2000 was in the like it came first and then 1000 and then 1. So when it went to callback stack, it executed in 3 to 1 order, right?
Yeah. So it executed
Okay.
in 3 to 1 order because we are self-executing itself. Over here, we executed this timeout.
Yeah.
We are telling this main thread to wait for 3 seconds, and we are making our debugger wait for 3 seconds. Iska matlab,
Yeah.
in the background, the 3 seconds are already done. It has moved to the callback queue. Pehli cheez, the first thing which entered the callback queue is this particular set timeout having console log 3. Then this particular set timeout having console log 2. And then at the end, this would enter, and then it's 3, 2, 1 again.
Okay, got it.
Without these threads, without making it explicitly wait, it would be 1, 2, 3, because it would be the way it got added inside the thread, the main thread. So let me
Yeah, but
re-execute this.
still I can manipulate the stack approach, right? When it comes, no, not stack, when it comes to callback queue and when it goes to callback stack, I can still manipulate in my code saying that, no, this is the expected process in any condition. I want the
No.
output to be 1, 2, and 3 rather than 3 to 1. I can't control code like that.
No. So you can't
Okay.
control, you can't put a priority upon these, asynchronous tasks. Maybe if you want to have such a control, you can say, okay, you can maybe do something like this. Puts a single set timeout. After 1 millisecond, it would execute. It will create another set timeout within a set timeout, and then it will again wait for 1 second. Maybe now you have a better, output, which is 1 and 2, and it would be consistent. Because what would happen is, let's put debuggers. So there would be a wait of 1 millisecond. Meanwhile, it will go further, get back to a callback function, which is this console log. It will again see a set timeout. It will make a background thread. Again, it will proceed further. After 1 second, it will return back to your callback function, and done. So the things are moving between the callback function and the execution stack. We entered the execution stack here. We went to set timeout. It made a single thread. It went further. Then this particular callback queue was waiting on the callback. So this particular callback function was waiting on the callback queue. It came back to the execution thread, which is the single thread over here, call stack. Then call stack again saw console.log. It made a console log. Then when it saw a set timeout, it created one more web API over here. It waited for 1 second, got back in a callback queue, and then it got executed inside a call stack.
Okay.
So what we can see is, if you are having any asynchronous programming in your application, your program keep on switching from the multiple areas. So you have call stack, you have things in web APIs. They keep moving around these 3 block of code.
Okay. Mm-hmm.
Okay. And this callback queue is FIFO, first in, first out. Whatever goes inside this callback queue first will be first executed. Anything which goes in a web API, any callback function associated to it will first get into a callback queue, and then when it sees that the call stack is empty, at that moment of time it will start executing. The second takeaway is every time, even if you have some asynchronous programming, each function executes in totality. It does not
Okay.
exit its normal flow until and unless the end of the function is achieved.
Okay.
Okay. So this is how it works. First of all, again, this is very different from what you have done so far in ASP.NET. Had it been ASP.NET, and even if you are putting a multi-threaded approach, all these set timeout and the callback function would have been executed by a separate thread altogether. Agree?
Mm-hmm. Yes, yeah.
Had it been a Java program, the set timeout along with a equal to a plus 50 and console.log would have been executed over here in this thread itself, not on the main thread. But JavaScript has altogether a different approach, which means that any execution that would be triggered would be there on call stack. Any asynchronous waiting, anything that makes you wait. Let's say if you are making an API call, if you're trying to extract data from some server in the background, it will make the network call. So the delay that has been taken in network call from making a request to the response, that part will be handled by the web APIs. Once the data is available, what has to be done with the data will be taken care by the call stack itself.
Okay.
Again, if it would have been Java or .NET, what would happen is asynchronous query will fetch some data, and that data manipulation will be done on the separate thread. But over
Okay,
here,
yeah.
what I'm saying is JavaScript is a single-threaded execution model wherein all the execution happens, and anything that has to wait goes on a web API. So in
Yes, yes.
totality, JavaScript is a single-threaded execution model containing a multi-threaded background architecture or infrastructure for asynchronous or the time-consuming task. Because this a is equal to a plus 50 is not a time-consuming task, that is not handled by web APIs. So web APIs are capable of only executing that time-taking execution, which is waiting for network, waiting for file system to get the data, or waiting for a set timeout, or waiting for a set interval. Rest,
Okay.
every execution is getting done on the call stack.
Yeah.
So now, if you relate back to it, so we'll be discussing more about this, in the session tomorrow. If you just look into it, this is it is entirely different from your ASP.NET. And once you are good with this thought process, that how JavaScript execute in the background, definitely when you are working with the program on Node.js or Angular or React, you will better relate to how actually your server might be working in the background, and you can make a better informed decision how to write code.
Yes.
So yeah, at any moment of time, you won't be confused why is this particular programming not working just like a multi-threaded infrastructure.
Yes.
Okay.
I can.
So if you know this particular stuff, you can relate why this is very different from multi-threading. Multi-threaded, had it been multi-threaded, we would have many problems like deadlocks. We can't ever predict out what is the value of A. Okay, because all of these functions might be executing A simultaneously. You don't know which one would be executed first because they are multi-threaded, and then you may end up with some inconsistent outputs.
Yeah.
Here you know which timeout is completing when, and then you can execute.
Yeah, the reason is like they all are handled by different threads, so we don't know which one would give an output first.
Yeah.
Yeah. Okay. Yeah.
So yeah, I mean, these are the things which I would like to draw your attention to in this, beginning of the session, and you will see, once we are done with these thought process, these execution models, Node.js is simply easy and a great language to learn,
Yeah.
because Node.js is entirely based on callback functions. So from now, you have to leave out that ASP.NET approach and you have to put callbacks. Any asynchronous process that you do, you have a callback associated. You say, okay, once this is done, do something further. For this, you have to learn what is context, what is closure, how asynchronous programming is working, what is happening in the background, how a function executes in totality, and so on. So yeah,
Okay.
I hope you liked this session. If you have
Yeah.
any feedback, you just provide me, because you have to bear me for next few days. So definitely, did you like the flow?
Yeah, it's good, and I understood this like very better approach, like all this set timeouts and like handling functions in this way. We don't do it more in the view pages for like, at least in .NET programming we don't have much of this stuff. So it's
So when
such.
you're doing a view page, when you're actually rendering, maybe you're dealing with the front end
Mhm.
as well. So do you make
Yeah.
AJAX calls?
Yeah, it depends. Like for some of the projects, we have a Ajax call. Some we
Yeah.
just go with the normal
So
Boolean
when you
hash
do a
table.
AJAX
Yeah.
calls, whenever you are doing any AJAX call, whatever
Mm-hmm.
is getting done inside a set timeout is exactly what happens in an AJAX call. If you are making an
Okay.
AJAX call, getting a network data from some
Yeah.
network on the server on a network, your main thread is proceeding further with the programming while you have created a thread which is waiting for data to be available from the network. Once the data is available, there might be a callback associated to that Axios or AJAX call, and
Uh-huh.
that
Okay.
callback would be executed back with the data which has been received. So now you can go back to your program and see whether there is a callback function associated with your asynchronous calls or not. Maybe now you
Hmm.
can relate better to it.
Yeah. Mm-hmm.
So if you can put debuggers in your program, go put a debugger and see that whenever a AJAX call was fired from your JavaScript function, it was executing in a synchronous manner. And then your asynchronous part or the AJAX call would be, once the data is available, it triggers the callback and further does something with the data.
Okay.
So yeah, just whatever we are just doing in the session, just try to relate it to your program. That way you will be able to connect more.
Yeah.
Definitely, we'll be working out with a lot of demos. We'll be working out with a lot of sample programs. I'll push all these code to the sample repositories so that you can give it a look.
Okay. Yeah. Sure.
So yep, at the end, any feedback from the session?
Yeah, the session was good. I liked it. It's like this approach is very nice. It's easy to
I mean,
understand asynchronous programming.
that's
Yeah.
right. When I ask for feedback, it's most of the time it's more about any negative feedback you have. So
Like
anything you want me to, you know,
uh, no,
do
in
further.
this like it's the first session. I'm not very much into this concept, so I don't have any negative things right now. But yeah, as we move forward, maybe I learn some more things, and then I can say,
Yeah,
okay, this is what I'm not feeling good about. It can be do it another way. So this is like my first class learning this asynchronous approach. So I found it good. This is nice. Yeah, as we
yeah,
go
sure.
deep into programming, maybe I would have some more thoughts.
I'll assure from my side that you don't get any such, thought process that you are not understanding the concept, you're not working with, you're not understanding stuff. I'll ensure that from my side at any moment of time. If you have any things that you are not able to understand, be very vocal about it, because I won't mind about that. Even if you say that the approach was not fine, you are not speaking well, I won't mind about that. Maybe that will help me out to better plan the next session that we have.
Okay,
Okay.
yeah, sure. Yeah, I'll let you know.
So yeah, sorry for today. Tomorrow we can start. at 6:30, and then from 6:30 to 8 we can continue a 1.5 hour session, and that is how we can cover the entire stuff.
Okay, sure.
Okay.
Yeah. Okay, Mike.
Yeah.
Yeah.
Thanks,
Okay.
Ritika.
Thanks.